Now our mode to determine I0 with the help of Thevenin's theorem. Okay, so how can do it? First of all, we have considered this terminal is X and this terminal is Y, and this one is, this 2 kilo ohm is behave as a load resistance. Okay, so how can determine? So basically our motto determine RTH and VTH corresponding to XY terminal. Okay, our motto determine Thevenin's equivalent corresponding to XY terminal. So how can do it? First of all, we have focus on VTH. VTH means V of open circuit. V of OC. Okay, V of OC corresponding to XY terminal. So first of all, make the circuit, that is 8 kilo ohm here, plus minus 12 volt, that is 12 volt, and that is plus minus Vx here 4 kilo ohm, and that is open circuit, here plus, here minus, that is plus minus 2 Vx, that is 12 volt, and here 4 kilo ohm. Clear or not? And that is minus, and that is V of OC. So basically our motto determine, first of all determine V of OC. So how can determine? This 12 volt is written here 12 volt, or better to write 12 volt. Clear? Now, so how can determine? First of all, apply KVL in this loop, here I1, here I2. Apply KVL in this loop, then determine minus 12 plus 8 into I1 plus 4 into I1, this is equal to 0. So what about I1? I1 this is equal to 1 milliampere. I1 this is equal to 1 milliampere. Clear? Now after that, what about Vx? And Vx is 4 into I1. Vx is 4 into I1. So 4 into I1, if put this value, then we got 4 volt. Okay, now apply KVL in this loop. Here minus 2 plus minus 2 Vx plus 12 I2 plus 4 I2, this is equal to 0. So what about I2? I2 is written as 2Vx. 2Vx means 2 into 4 divided by, that is 16. So 8 by 16 means 0.5 milliampere. Okay, now apply KVL in this loop. Minus 2 plus minus V of OC plus Vx. Vx is 4, and current going on here to here. So minus I2 is 0.5 into 4, this is equal to 0. So V of OC, this is equal to 4 minus 2 volt. Okay. Now next target is our motto determine RTH. So how can we determine RTH? I know that all independent source reduced to be 0. This one independent source, that's why reduced to be 0. And after that circuit, make the circuit, that is 8 kilo ohm, that is short circuit, and here plus minus Vx, that is 4 kilo ohm, and this one is make 4 kilo ohm, here 12 kilo ohm, here plus minus 2 Vx. Okay, plus minus 2 Vx, and now you can assume 1 volt voltage source, or you can assume 1 ampere current source. Okay, if you consider that is 1 volt voltage source, okay, then what about current? That is current is I. Okay, that is X and that is Y. Okay, and this one assume is a ductile node. I know that 1 volt, basically 1 volt means I into RTH. So basically our motto determine RTH means 1 by I. So okay, so our motto determine I. How can determine I? Now look, if this one is 1 volt and this one is Vx and this one is Vy, clear? We have considered that is Vx and here Vy, and that is 0 voltage. This voltage is same as Vx. If you consider that is V1, then V1 this will be equal to Vx because there is 0 voltage. V1 minus 0 this will be equal to Vx. So you can say that V1 this will be equal to Vx. So you can write now here that is Vx. Clear? Now if this one in this branch current and this branch current, assume here I1, here I2. Okay, now here I3, here I4. Okay, so first of all, what about I? I is written as, apply KCL at that node, I1 plus I2. I1 is written as Vx minus 0 divided by 8. Vx divided by 8, and this one is also written as Vx divided by 4. Vx minus 0 divided by 8. Okay, so what about this value? That is 3Vx divided by 8. I this equal to 3Vx divided by 8. Now next target is I3 plus I4 this equal to I. You can say that I3 plus I4 this equal to I. What about I3? 0 minus Vy. 0 minus Vy. 0 minus Vy divided by 4. Now here 0 minus Vy and minus currently from positive terminal, so plus 2Vx divided by 12 this is equal to I. Okay, now that is 3, and that is, if solving these two, that is 3 Vy minus Vy plus 2 Vx divided by 12 this is equal to I. Okay, I know that Vx minus Vy this is equal to 1 volt. Vx minus Vy is equal to 1 volt. So you can say that Vy replace Vx minus 1. Vy replace Vx minus 1. Now if this value put here, then we got minus 3 Vx, that is minus 4 Vx minus 1 plus 2 Vx, this is equal to 12I. So minus, this is minus 4, and that is, so find 2 Vx, and this is minus 4, so plus 4, this is equal to 12I. Okay, now here what about Vx? Vx in the terms of I, 8I divided by 3. If this value put here, minus 2 into 8I divided by 3 plus 4, this will be equal to 12I. So 4 this will be equal to, if this one is going on here, then 16 by 3 plus 12I, that is 52. So finally 1 by I is 52 by 12, that is 4.33 kilo ohm. Okay, and this one is basically RTH. This one is basically RTH. So our next target is determine I naught. So make this circuit plus minus, and here RTH, and here I naught, and that is 2 kilo ohm. Okay, and this one is VTH. VTH is 2 volt. Here RTH, that is 4.33 kilo ohm. So what about I naught? I naught is written as VTH divided by RTH plus RL, that is RL. So put this value, 2 divided by 4.33 plus 2, that is 6.33. Okay, 6.33. Then we got 2 divided by 6.33 is 3 point, we got 0.316 milliampere is the right answer. Clear or not? Okay, so I naught is clear. So how can determine? Simply, first of all, this one is open circuit, then determine VFOC. After that, determine RTH. RTH basically 1 by I, and then put this value and we got I naught.